We have 4 basic measurement systems that we use to gather data from our subjects, and they're listed on the table. Nominal, ordinal, interval, and ratio, and they help us understand how our subjects vary from one another. Many of the measurement scales we use in everyday life possess all 3 of these properties. An example of a nominal scale is the naming of cars, for example, or the classification of animals, or of personality type in people. An example of an ordinal scale would be ranking children according to their heights, with the shortest child receiving a rank of 1, and the next tallest a rank of 2, the next tallest a rank of 3, and so forth. Possesses the property of magnitude, but not of equal intervals because of the difference in heights. An example of an interval scale is the Fahrenheit or Celsius scale for measuring temperatures. For all practical purposes, the temperature scale lacks an absolute 0. A ratio scale is a scale with a collection of properties that allows ratio statements to be made about the attributes being measured. For example, if an adult is 75 inches tall and a child is 35 inches tall, it's correct to infer that the adult is twice as tall as the child. A scientist can construct a ratio scale from measurements derived from the use of a tape measure. The difference between an interval and ratio is that a ratio scale has an absolute 0, where, for example, it's possible to get no answers correct, take no time to complete a task, or not gain any height in the last year. Conversely, in an interval scale, using the Fahrenheit scale for example, the value of 0 does exist on the scale, but it doesn't represent the absence of hotness or coldness. On the previous slide, you were introduced to the 4 basic measurement systems we use to collect data from our subjects, and to measure how our subjects vary from each other. When we're using a nominal or ordinal measurement scale, the numbers we use are whole numbers, and they're considered to be discrete variables. An example of a discrete nominal scale would be number of children, number of people who drive Fords. An ordinal scale is used to create a ranking system. An example of that might be first place in a race, second place, and so forth. You would never say that you have 2.5 children or that you are 1.5 place, so discrete variables are based on whole numbers. Conversely, when it is important to measure something very precisely, often whole numbers are divided into decimal places. An example might be the need to create a clock that can measure the difference between the first and second place times of Olympic athletes. Sometimes that difference is in hundredths of a second. So when it is important, within the context of a research project, to measure subjects in a very precise way, less than whole numbers, the term we use is continuous variable. When it is important to measure very precisely, and we use decimal points to measure a continuous variable, then we must map out the boundaries of the number. A real limit for a number is a half measure above the number and a half measure below it, just like you see on the slide. The boundaries of the number 150 actually start a half measure below the number at 149.5 and extend to a half measure above the number at 150.5. That allows us to associate any measurements, like those shown on the slide, 149.6 or 150.3, with the number 150.